네, 여러분 안녕하세요. 네, 제가 좀 봤더니, 네, 진도가 느려요. 네, 그래서, 네, 좀 빨리 나가야 될 것 같아요. 어려워요? 지금까지 한 것 중에 어려운 거 하나도 없잖아. 다 아는 거 아니에요? 네. 네, 별로 어렵지 않아요. 네, 다 아는 거 하고 있어요. 지금까지 한 중학교 정도 수준의 수학만 하지 않았나요? 지금까지? 더하고 빼고 나누고. 네, 중학교 정도 수준 하고, 수학하고 있었죠. 그래서 저번 시간에 한 거는, 네, 우리 discrete random variable에 대해서 x가 있을 때 x를 fully define 하는 게 PMF죠. PMF가 각각의 x가 어떤 값을 가질지의 확률에 대한 함수니까 이 PMF가 주어지면 x가 fully define 된다. 그리고 그것과 동등하게 CDF라는 게 있어서 CDF가 PMF는 다시 말하면 Px of x는 probability that x가 어떤 특정 값 스몰 x를 가질 확률을 나타내고, 그다음에 CDF는 얘와 PMF와 동등한 인포메이션을 갖고 있는데 우리가 large F로 표시하고 정의는 probability가 x가 스몰 x보다 크거나 작을 확률. 두 개는 하지만 동등한 정보를 갖고 있다. 그래서 둘 중에 하나만 있으면 x를 우리가 fully define 할 수 있다라는 것을 배웠고요. 근데 뭐 다시 말하지만 항상 사람들이 어떤 이런 복잡한 함수를 이용해서 x를 define 하는 게 아니기 때문에 x를 우리가 이야기할 때 x라는 게 어떤 랜덤 베리어블이라는 걸 이야기하기 위해서 간단하게 하나의 숫자를 제공할 필요가 있는데 그 숫자가 바로 expectation이다. 그래서 ex라고 쓰고, expectation은 뭐 우리가 보통 말하는 평균 혹은 average, mean 이라고 말하는 게 expectation이고요. expectation은 정의 자체는 x에다가 이 PMF를 곱해서 P of x를 모든 해당하는 x의 값에 대해서 해주면은 요게 바로 expectation의 정의다 라는 것까지 했었죠. 그리고 이제 오늘은 새로운 것으로 이제 우리가 많이 했던 그 여러 가지 common random variable에 대한 expectation에 대해서 보도록 하겠습니다. Okay, so today, we're gonna keep discussing about the expectation and especially for the common random variables. For the Bernoulli, in the Bernoulli case, P of x is P when x equals 1 and it's 1 minus P for x equals 0. So simply by using this, the definition of the expectation, if we calculate it, 0 times 1 minus P plus 1 times P equal to P. Then expectation of Bernoulli random variable is P. Simply calculate it. And how about the geometric random variable? For the geometric random variable, because PMF is given in this way, so expectation is, because that its sample space is from x equals 1 to infinite, we calculate x times p times 1 minus p to the x minus 1. Then if you're doing this complicated calculation, then the result should be 1 over p. But without doing the complicated calculation, we can simply think it's 1 over p, right? Because geometry itself means the number of the random trials, Bernoulli trials, up to first success. That means, easily speaking, we say fail, 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 and fail, and see the first success, right? And this total number is, we can say, so what's this total number itself is x, random variable x, and this random variable is represented by expectation of x. Then with this expectation of x, we see one success. Then if we intuitively calculate the probability is 1 over ex, intuitively, right? Because among ex trials, we see one success. That is, should be equal to, that's the probability of success, P. So here, ex is intuitively 1 over p. We can see 1 over p. Okay? Similarly, for the binomial random variable. Binomial random variable means in total, n trials, right? N trials. And among them, we have some successes. Successes, fail, successes, success, fail, blah, 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 blah. And random variable x means number of success, right? Then this one is represented by ex, expectation of x. And if we very intuitively or very roughly, if we roughly calculate the probability of success, it should be n over ex, right? And that probability should be p. Am I right? Then from here, we can intuitively or very roughly calculating, we can see the np. However, definitely this is very rough and incorrect. It's not mathematical approach. It's a mathematical approach, but it's a very intuitive approach, not the exact approach. Exactly, you should calculate, because for the binomial random variable, the PMF is given in this way. So you need to calculate x times this kind of, the very complicated, probability function. That is x times whatever. Okay, this should be x. This k should be x. This is a typo. This k should be x. And something, something, something. Then if you calculate this one, that is np. Okay, this is a typo and this is a typo, right? They are all typos. Can you calculate this equation? This is actually, if you want to formally calculate the expectation of binomial random variable, you need to calculate, start from x equal 0. I should be from 0. But it doesn't matter because x equals 0. Anyway, x equals 0 to n, and x times x factorial, n minus x factorial, n factorial times p to the x, 1 minus p to the n minus x. You should calculate these equations. Can you calculate it? Oops. Zainab, can you calculate this equation? It's this equation. The formal calculation of the expectation of a binomial random variable. Maybe not that easy, right? It is not that easy, but you don't have to calculate it because someone already have calculated it. So you don't have to do. But important thing is you need to understand why the result is NP. That the reason is here, intuitively, we can see in this way. So total number is n, and expected success is EX, and the ratio should be equal to the probability. Then we can easily say EX is NP. Am I right? You got it? Okay. Then similarly, you can see the negative binomial random variable and the Pascal random variables. Similarly, okay. So please, at your home, please think about how you can intuitively calculate the negative binomial random expectation of negative binomial or Pascal random variables. Okay, intuitively. And the uniform. Uniform is easy because uniform is between K and L. It's uniformly distributed. So the expectation is just in the middle. So it is k plus L over 2. That's the expectation. And Poisson random variable case, it's alpha. Why? Why it's alpha? 남영규 학생. 네. 왜 Poisson 랜덤 베리어블에서 expectation이 알파일까요? 자, Poisson 랜덤 베리어블이 뭘 뜻하죠? 그러니까 어떤 거를 보통 표현 모델링 할 때 우리가 쓰이죠? 네, 그 Poisson 랜덤 베리어블은 일반적으로 네, 어떠한 타임 시간 동안 이벤트가 몇 개 발생하냐를 모델링 할 때 써요. 그래서 이벤트가 뭐 10개냐, 11개냐. 근데 알파는 뭐냐면은 요 기간 동안 평균적으로 알파 개의 이벤트가 발생할 때 실제로 알파 마이너스 1개 혹은 알파 플러스 1개가 발생할 확률을 의미하는 겁니다. 자, 그럼 왜 평균이 알파죠? 그렇죠. 네. 자, 이해하셨죠? Okay, the reason that the expectation of Poisson random variable is alpha is because, as you see, the Poisson random variable represent the number of events when on average, the number of events is alpha, right? So definitely you can prove it formally because you know the PMF of the Poisson random variable. Then you can calculate it. However, it wouldn't be that easy. I don't know, so I'm not sure. But by myself, I cannot do that. But you guys might be do that. 작년 시험 문제에 이 파스칼 랜덤 베리어블의, 네거티브 랜덤 베리어블의 그 익스펙테이션을 구하라는 문제를 냈는데, 저는 인투이티브하게 여러분들이 설명할 줄 알았는데, 그걸 계산하시더라고요. 네, 그래서 놀랐어요. 네. 계산하시는 분, 대부분이 다 계산해서 풀어내야 하더라고요. 그래서, 이 계산이 가능했구나. 저는 불가능할 줄 알았거든요. 전 불가능할 줄 알았는데, 네, 계산하시더라고요. 네, 진짜 훌륭한 학생들인 것 같아요. Okay, so, any question? Okay, so let's see, this example. So this example is, okay, so you are transferring message with your cell phone, then, and when you send the message, sending a message takes 10 cents, but receiving takes 5 cents. And the probability for the sending a message is 1/3, and the receiving probability is 2/3. Okay? Here, C is the cost. C is a random variable for the cost for a message. Okay? C is a cost for a message. Okay? So what is the sample space of C? 자, 이 문제에서 뭐냐면은, 자, 우리가 텍스트 메시지를 보내는데, SMS 메시지를 보내는데, 보내면 10센트를 내야 되고, 요금이, 받으면 5센트를 내야 돼요. 그럴 때 C가 그 메시지 하나에 대한 코스트에 대한 랜덤 베리어블이에요. 그러면 C의 샘플 스페이스가 뭐죠? 네. So C's sample space is, or C's value can be 1/5 or 10. Okay? But C itself is a random variable for the cost for a message. Okay? then what's the probability of, what's the PMF of C? PMF of C should be 1/3 when C equal 10 and 2/3 when C equal 5. Okay? And 0 for otherwise. Okay? First question is, what's the expectation of C? Expectation of C. 자, C의 expectation 얼마죠? 이러한 상황에서? 네. The expectation of C is, it's very simple, right? Expectation of C is 20/3. Very simple. You got it? Isaac, you got it? Why the expectation is 20/3? No? No? Oh, you cannot see this one? We are actually solving, this example. So the PMF, so the problem 1, problem A, PMF of C is 1/3 when C equal 10 and 2/3 when C equal 5. And then expectation is, by its definition, C and P, C over C, PC of C. Then this is the actual value of C, and this is the probability. And this C can be 5 or 10. When it's 5, the probability for the 5 cents is 2/3 plus when C equal 10, the probability for 10 is 1/3. So that's why it's a 20/3. Okay. Then please try the C and D by yourself. Okay. So any question for the expectation? 자, 여러분 expectation 별로 안 어렵죠? 네, 그냥 하면 돼요. 네, 하나도 어려운 거 없어요. 오케이. 자, 그 다음에 넘어가서 여러분 진짜 안 어렵죠? 아, 어렵다. 거기 제일 뒤에, 예, 거기 검은 옷 입은 학생, 네, 어려워요? 예, 방금 고개 이렇게 저은 학생. 네. 안 어렵다는 뜻이죠? 네. 감사합니다. Okay, so let's move to the next topic. Next topic is for the derived random variable. Derived random variable. So, let's think about the random variable x, and certain y is derived from x through the certain function of g. Then we say y is a derived random variable. Derived random variable, okay? Then definitely we say it's like that. So let's think about x has its PMF, Px of x. Okay? Then y is certain g of x, and the g is a certain function. For example, it can be, let's say, 2x plus 1. This is the kind of a function of x. Then y is calculated by this function. So in general, let's say g of x. Then here the problem is, our goal is to find out what's the PMF of y. That's our goal. So we know the PMF of x, and we know the relation between y and x. Then we want to calculate the probability distribution of y. So Py of y is, by its definition, probability that x is not x, y is equal to y. Then this y is probability that g of x, because here is y. That means when you put any value of x, okay, if its result is equal to the y, then that probability should be counted for here. So this one is calculated by any x that makes g of x is equal to y. For all of this such x, we add px of x. Okay, so you might think that this is a little bit confusing, but with this example, it is very clear. Okay, let's think about, we are monitoring 3 customers purchasing smartphone at the phone smart store and observe whether each buy apricot phone or banana phone for $300. And the random variable n is the number of customers purchasing apricot phone. Okay, so we have the three customers. So we have 3 customers, 1, 2, 3, and each of customer can buy apricot phone or Apple phone or Samsung phone. Let's say banana phone. Phone A or phone B, or the Apple phone or Samsung phone. And this customer also can buy Apple or banana, apricot banana, or the A and B, A or B. And the N means number of customer for phone A. They're buying A. So it can be 0, 1, 2, or 3. Right? And the probability is given in this way. The probability that n is 0 is 0.4, n is 1, 2, 3 is 0.2. Am I right? Is it right? Okay, so that's the setting of the problem. All right? So here, is random variable n, and this random variable n has a sample space 0, 1, 2, 3. Okay, then for 0 it's a 0.4, and this one, they are all 0.2. Probability is a 0.2. And here we want to define new random variable m. M is a dollar, is amount of money paid by 3 customers. 3 customers, okay? So here is a new random variable m. Okay, so if there is no, so when n is 0, that means nobody buy apricot phone. All buy banana phone. Then what's the value of m in that case? Huh? Because each banana phone takes $300, and all of the 3 customers buy, so 900. So 900. It goes 900. And how about this one? 1. How much? 10, 50, and in this case, how much? 1200. In this case, 1350. Okay? And what's the probability for the 900 then? What's the probability of 900? 0.4. And then we can say, we can calculate the PMF of M, right? So PMF of M is 0.4 when M is 900 and 0.2 when M is 15, 12, and 1350, and 0 for otherwise, right? Then, okay, then, but here, if we express M as a function of N, so definitely M is the function of N, right? So how can we express it? So N is number of customers that buying banana phone. Am I right? No. Africa phone. So here, each Africa phone takes 450 times N, because the M is the total number of dollars, plus then number of customers that buying banana phone is 3 minus N. So 300 times N minus 3. So this is a function between M and N. And according to this function, we can calculate the values of M, and according to that, we can calculate this one. Okay? Then what is the expected value of M? What is the expected value of M? M의 expected value 얼마죠? 이러한 상황에서? 계산할 수 있죠? So can you calculate the expected value of M? M's expectation? Yes or no? Yes, definitely. It's not difficult because we have a PMF here and we know each value. So you're just doing a simple mathematics. Okay, so in many cases we have this is the typical example. So simply this random variable n and random variable m, they have a certain relation like this, and according to this relation, you can build this kind of mapping function, and from this the mapping diagram, you can get the easily get this PMF of new derived random variable. Then you can calculate everything. Okay. Then let's move to the next. Here, this part. Okay, so let's think about what's the expectation of the derived random variable actually. So if you think the somewhat okay, for the random. Okay, so let's think about y is a derived random variable from x through the function g. Then if we want to calculate the expected value of y, then y, then by definition, it is given as y times PMF of y by its definition. Then it should be equal to g of x times PMF of x. That means in order to calculate the expectation of y, we just use the PMF of the original random variable and the relational function of g by applying this the function to the each variable x. Okay, so let's prove it. Why it should be make sense. Okay, so we calculate EY, and by definition, this is the y, py of y. Okay, and for each specific y, so this is the y for all y's of y, and for each specific y, there is set of x. That is, g of x is equal to y, right? Then here's y. This is for specific y, and p y of y. But in here, this y is for all of x values in this summation. This summation is for x. This y is for x. So first summation is for y, and second summation is for x. This y should be g of x. Right? Okay. And p y of y. No. Let me get back. Let me get back. So this should be. So this is a more confusing way. Okay. So it can be rewrite. Okay. So how can I say that? So okay. So this is the summation over y, and this summation is for a specific y. Okay, this summation is for a specific y. For a specific y, okay, so let's get back. For a specific y, so we have y and the p y of y. Okay, for a specific y, so there is a set of x because p y of y is the x that satisfies gx equal y of px of x. So for a specific y, this y can be replaced by this summation. So this one is equal to x that satisfying gx of equal to y and px of x for a specific y. So it is like this. So here is sx and here is sy. And in sx, here's x1, x2, blah, 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 xn. And in the y, we have y1, y2, blah, blah, ym. And throughout certain function of g, certain x's are mapped to y throughout certain function of g, x. Then for a specific y1, this x1, x2, let's say x3, these x3s are all combined to the specific of y1. So that part is represent this mapping. Multiple x is mapped to the single y. Okay? So we can rewrite in this way. And this is specific y. So this y can be also replaced by, because for all of x, this is this equation is satisfied. So this one is replaced by then it get into this one, and it's g of x here. So if we calculate this one, again, we summate over all y, and we summate over all x that satisfy gx equal y, then gx and px over x. Okay. This double summation means for this y we summate over all x, and for this y we summate over some x, and for certain y we summate certain x, blah 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 blah. Then if we add up all of this double summation, this is a summation over all x. So this is a summation over all x. Then it's the gx of px of x. Okay? It is very simple. So actually from the previous example, gx previous example, so you may see this is a little bit confusing, but this is very intuitive. So for the previous example, so we have relation that m is 5n plus 300, 3 minus n, right? This relation. So if we want to calculate EM, we just summate over n is from 0 to 4, and that is 540n plus 100, 3 minus n times Pn of n. So it is very natural because for each n, this is the probability of each n, right? And this is the money when n is a specific n, right? Then that's the expected number of the sales. So it is very intuitive. 자, 여러분 무슨 말인지 아시겠죠? 그러니까 사실 이게 함수를 이용한다는 게 사실 되게 단순한 일이에요. 그냥 되게 인투이티브한 일이죠. 그러니까 예를 들면 아까 그 예제에서 우리가 지금 보면은 그 손님이 몇 명인가에 대해서 확률 분포가 있었죠. 근데 그것에서부터 우리가 실제로 판매 가격이 얼마인가에 대한 확률 분포를 찾고 싶은 거잖아요. 그리고 익스펙테이션을 찾고 싶고. 근데 그걸 계산하는 거는 사실상 손님이 한 명일 때 예상되는 매출이 얼마고 손님이 두 명인데 예상되는 매출이 얼마고 그걸 다 더하면 되잖아요. 그러니까 지금 손님이 한 명일 확률, 손님이 한 명일 경우에 매출. 요게 바로 G of N으로 주어지는 거죠. 요 공식에 따라서. 그래서 지금 보면은 expectation of M은 그러니까 어떠한 함수에다가 확률 분포를 곱한 거에 서메이션으로 주어진다. 라는 거죠. 자, 졸지 말고, 네. 정신 차리고요. 쉽죠? 쉬워요? Okay, so then let's make an example. Another example. Okay, let's think about what x is. Okay, so we are doing the discrete random variable. So, but let's make the example, some interesting example for the continuous random variable. Okay, let's think of x is height of Korean girls. Okay. Okay, so this is the continuous random variable, but similarly, you can think what's the expectation of x, or average, or expectation of x. Let's say unit is meter, not inch, not feet, meter. So, what do you think? What's the expectation of x? 평균 몸무게가 얼마 정도 돼요? 아, 평균 키. 아, 죄송해요. 몸무게를 물으면 안 되지. 네, 평균 키가 얼마 정도 돼요? 미터로? 네? 1.6. 네, 1.6. So, let's assume the expectation is 1.6 meter. Okay? Then let's think about y is same height of the same Korean girls in centimeter. What's the relation between x and y? What's the relation in x and y? So y is the random variable for the height of the Korean girls in centimeter. So y is 100x. Then expectation of y is 160. Okay? So you see it is very natural, okay? Then let's think of the G. G is height in Korean girls in centimeter with 10 centimeter here. Then what's the relation between G and X? Then G is 100 times x plus 10. Okay? Then what's the expectation of g? 170. Am I right? Definitely 170, right? So nothing difficult. 자, 여러분 지금 그러니까 그 평균 키가 미터로 1.6m예요. 네. 한국 여성의 키가. 근데 그걸 센티미터로 바꾸면은 100을 곱하죠. 그럼 평균 키가 얼마가 돼야죠? 160. 그쵸? 거기다가 근데 그때가 아니라 이제 힐을 신었을 때, 힐을 신었을 때 평균 키를 재면은 170. 되게 간단한 거 하고 있죠. So in general, so it is like that. So we see EX is 1.6. However, expectation of G, which is expectation of 100 times X plus 10 is equal to, we see 100 times expectation of X plus 10. That's actually what we have calculated intuitively. So in general, in here, if y is ax plus b, then expectation of the ax plus b is equal to a times expectation of x plus b. So in general, that holds. So that's the good relations, right? Okay, you got it. Then okay, so then we know the third one. Then how about this one? Okay, so let's think about the constant one. Constant one. Okay, what's the expectation of a constant one? Okay, so for the constant one, what's the probability that constant 1 equal to 1? 1. What's the probability that constant 1 is not, is the any other value? 0. So expectation of any constant, any non-random variable should be 1 or x itself. So expectation of the constant should be constant itself. Okay? And for any random variable of x, expectation of x, is it constant or random variable? No, x is a random variable. How about expectation of a random variable? Is it constant or random variable? It's a constant. It cannot be changed. Right? There's nothing random because we picked a number. So EX itself is, so X is a random stuff, but expectation of that is not a random stuff. Okay? So that means expectation of expectation is X. Okay? All right. So here, then let's see the second one. Expectation of x minus EX. So by the third property, AX plus B equal to A times EX plus B. So this expectation is applied to here. EX minus, then because of this one is constant EX, and it should be 0. Okay. Okay, then let's see the third one first. Third property first. Let's formally prove the third property. So we intuitively see the third property that so expectation of ax plus b. So let's see this third property. Okay. So let's think about y is ax plus b. Then this is an expectation of y. Then in here, our relation function between x and y is, let's say that's a gx, that's a ax plus b. So this one is gx and px of x. And this gx is linear relationship with ax plus b. So this is ax plus b times px. Right? Okay. Then this one is ax px plus b times px. And this summation is for all x. This one is a constant, and b is also constant. So this is a and x of p of x plus b times p of x. What's this one? Expectation of x. So here's a. So a and expectation of x plus, what's this one? What's the summation of the all PMF over all x? It's 1. So it's b. So we can easily see this one is like this. I didn't note in here, but in general, for any random variable x and y, any random variable of x and y, expectation of ax plus by is equal to a expectation of x plus b expectation of y. So you can also easily prove it for any random variable x and y. Okay, so please do it at your home. So it wouldn't be that difficult. Okay, so but in general, expectation of g of x is not equal to g of expectation of x. In general, if gx is a linear function, that means if gx is ax plus b, this one is a whole. So as you see here, if gx is ax plus b, expectation of gx is equal to gx of ex. It holds. However, in general, for the in general function of gx, it doesn't hold. That example is like the second order function, like y equal to the square of x. When y equals square of x, and it doesn't hold. Okay, so in order to check it, so please, solve this problem by yourself. So please calculate. Okay, so in here, what would be good one? Let's do it this problem with me, and please solve out this problem by yourself. Okay, so let's see the first one with me. Okay, so let's think about this px. So Px is one color for x equal 1, 2, 3, and 4. And what's the best random variable that describe x in this case? What's the common random variable that can describe this x? 자, x의 PMF가 저렇게 주어져 있어요. 그쵸? 그러면은 이 x는 우리가 배운 랜덤 베리어블 중에 어떤 랜덤 베리어블에 속할까요? Uniform between 1 and 4, right? So x is unique between 1 and 4, actually. Then gx is given in this way. So it is like this function. So 1 and 5, it is kind of this kind. And after 5, it's a 500. It's a 500, but before 5, so it is kind of this kind of. If it's 0, it's 100. Something like this kind of function. I guess. Maybe not this kind of function. Maybe I don't know, but this is maybe this kind of function. Hopefully, yes. It's this kind of function. Okay. So let's calculate expectation of y in this sense. So because all of the x should be located in between 1 and 5. So this is only our function. Okay. So expectation of y is when x equal from 1 to 4, then we do this one, 105x minus 5x squared. And each PMF of x is 1/4. So we simply calculate this one, then we can calculate the expectation of y. Okay? 맞나요? 제가 여러분이 잘 모르는데 맞다고 대답하라고 강요하는 건가요? 보통 강요하는 것처럼 느껴지죠. 그래서 에이 잘 모르겠지만 그냥 대답해주고 말자. 에이 내가 들었고 지사해서 대답한다 뭐 이런 식으로 하지. 네. 근데 뭐 별로 어려운 건 아니니까 네, 한번 해보시면 되고요. 자, 오케이. So please do it this problem by yourself. 자, 이 문제 한번 5분 동안 한번 해보시기 바랍니다. I'll give 5 minutes and please try to do this second problem by yourself. 자, 여러분, 제가 지금 빠르게 한번 해볼게요. Okay, so let's see how we're gonna solve out this problem. First problem is the expectation of A. EA. So A is the PMF of A is given in here. So A can be 1 or 2 or 3 or 4. But probability for 1 is, what's the probability for 1? 0.4. And for 2 is 0.3, 0.2, and 0.1. Then the expectation of A is, because with 0.4 probability we observe 1, and with 0.1 probability we observe 4. So the expectation of A is what is expected, or on average, what's the value of A? Then we just multiply this one, and summate everything. Okay? Then what's the answer? 2. All right. And problem B. M is a number of memory chips as a function of GA. Okay. Okay. So let's express the second problem is to find out this function of G, right? So what's this function? So in here, for when A is 1, M should be 4. When A is 2, M should be 4. And when A is 3, it's 6. And for 4, it's 8. So we can easily define G of A is equal to 4 when A is, but I like to use A is 1 and 2A and way is 2 and 3 and 4, maybe 0 or otherwise. Well, something like that, right? So this is the definition of the function GA. Then we satisfy. We can find out this one. Okay, but definitely if you like, so you can say you do 1, 2, and 3, 4, but it doesn't matter. Then what's the expectation of M? What's the expectation of M? So EM is, by definition, GA, let's use small a, and PA of A. That is, when A is 1, GA is 4, and the probability is 0.1. And when A is 2, GA's value is also 4, and that probability is 0.2. And when A is 3, M is 6, that probability is 0.3, am I right? Plus 8 times 0.4. And the total? In total? How much? 반대로 됐니? 예. This should be 4, 3, 2, 1. In total, how much? 4.8. Then third question is, please check. So definitely, the expectation of M is expectation of a function of G of A, definitely, by definition. Then please check whether this expectation of M is G of EA itself. What's the EA? 2. Then what's the G of EA? So because this is a 2, what's the G of EA according to this function? According to this GA? Okay, so it's confusing. So because this GA's value is 2, right? Then what's the G of 2? According to this function, it's 4. So is it equal to this one? No. So in general, okay. Okay, so the number first here, E of G of X. So the expectation of the derived random variable is not equal to the derived function of the expectation of the original variable. So this one, in general, it doesn't hold. 맞나요? 네. 그 다음, 여러분, 수고하셨고요. 오늘은 좀 빨리 나가서 이해가 안 되는 부분이 있을 수도 있으시면, 스스로 공부, 복습, 친구한테 물어보고, 그러시기 바라고요. 다음 시간에는 베리언스 하고, 남는 시간에는 시간이 남으면 퀴즈를 보도록 하겠습니다. 수고하셨습니다.